Now let's see together the steps we use to create our CID file in a simple way. Okay? We agreed that our IED, whether it's the PCU, the PCPU, or even the protection relay, is the link between your field components like the switch gate or the GIS and the substation automation system. Therefore, you have this CID file where you want to include a set of configured signals that you want to send from the switchgear or GIS to the substation automation system to start monitoring and controlling your system. So, whether you are sending from your field to the SAS or receiving from the SAS to your field, you had hardware binary inputs representing alarms, statuses, indications for you, or hardware analog inputs representing measurements for you, in addition to a set of commands that are received from the SAS on the fixed components, which are the disconnector, earth switches, or circuit breaker, which represent for you, in addition to a set of which are received from the SAS on what? On your field, which is the circuit. Are these communications sent from the relay to the SAS or received from the SAS to the relay? No, there are also other things. What are the other things? You might have something like the virtual signal or the software signal that comes out of the protection functions, such as tripping or pickup, depending on the communications you need to program. It can also be logic. It's not necessarily that I take the alarm and send it at once. All the alarms might come to me in the form of a binary input, and I might delay it, for example, with a timer or a guide time, or I might link it to a specific status. I mean, I create internal logic within the relay. The important thing is that in the end, everything we want to send from my IED relay to the SAS falls under the categories of alarms, statuses, indications, measurements, or commands. So all these messages I will call from the relay in the form of one of two things, either a standardized logical node or a generic logical node. Standardized logical node or generic logical node. Very nice, okay? I take the standardized logical node or the generic logical node and place it inside something we call the dataset. Then after that, I link this dataset to a number of reports depending on the number of servers to which I want to send this data in your station. It could be 4, 5, 6, depending on what you have. Very nice. Okay, let's also see together, to simplify the idea, what all this means in detail. Let's assume you have a relay and I perform an X-ray on it, or I make a section or cut into it to start seeing what is inside my relay or how the programming is done. The first thing you have externally, we call it something called the physical device. This physical device is the actual IED. Very nice, okay. Inside this physical device, I find something called the logical device. What is the logical device? It is a group of logical nodes, inside your physical device. And the logical device consists of control, measurements, protection, records, and system. Of course, the relays might have slightly different names, but in general, these are the logical devices that exist. For example, you have something called a logical device named control, and this control is inside a group of logical nodes, and the same goes for measurements, protection, and so on. You could say that this is a group or a specific category that contains a set of logical nodes. So inside the logical device, we agreed on the logical nodes. So what are these logical nodes? These logical nodes are the major function areas. What is meant by major function areas? Something like a circuit breaker or something like measurements. What does this mean? For example, if I came to you within the measurements, within these measurements, you would find something called a logical node, for instance, named CMMXU, which is specifically for current measurements. You have, for example, VMMXU, which is something specifically for voltage readings, something specifically for reading residual components. Regarding the planes and voltages, and so on, for example, also XCPR1, which is specifically for the circuit breaker, might be found under control. So we have entered and found a group inside each one, meaning control is not just inside one thing, nor is it just inside one thing, but a group of, but both them. Well, if you took this and focused more on it, for example, if you took something like, for instance, the mixer, which is, for example, the current measurement. So inside this logical node, I find something called the data object. This data object identifies the type of data you want to use. What does this mean? For example, if it is talking about measurement, then you are talking about the ampere reading, for instance, of the ampere or reading, for example, the voltage reading or the power reading or the constant current or whatever. And if you are talking about something, for example, like the circuit breaker, which we call the logical node of the circuit breaker, then you could be talking inside about something, for example, like the position of the circuit breaker, close or open. Close or open, right? Okay, inside the data object, I have something called the data attribute, which is the description of your data, which is the actual data you need. For example, if you are talking about current, you want phase A, phase B, or phase C. If, for example, you are talking to me about the status of a circuit breaker, you are referring to the position of your circuit breaker, whether it is closed or open, right? So I was able to dissect or take an X-ray of my relay and understand how I can access my signal. So I have my physical device. The next thing inside it is something called a logical device. Inside the logical device, I will search for a logical node, then I will look for the data object, and from the data object, I will search for the data attribute. Of course, if you already have experience with this, you might say to me, Engineer Ismail, we already know. We go directly to phase A or phase B. I know where I use it all the time. But I want to clarify something for you, that the address, as I wrote, tells you that when you're looking for something inside, you have to follow the order I'm explaining. And keep in mind the number of signals, as we know when we program the relays later, and you will see it with me in practice, that the number of signals will be determined by the data attributes. You will be told, for example, that you are allowed a certain number of data attributes, not a certain number of data objects or logical nodes, but by data attributes. Okay? So that's why I wanted to explain how the whole topic is active.